Welcome to part 3. We're going to take a look at some basic Solaris and USD concepts. This is a more broad sections just about Solaris, so if anything wasn't clear in the first 2 sections, I hope this is going to clear it up. Like I said at the beginning, I would advise anybody who's not familiar with Solaris to watch this first and then maybe watch the first 2 videos next, but let's do it. All right, let's continue with some more basic examples and how to merge and bring things into Solaris, because we can merge things with graph stages, sublayers, graph branches, with merge nodes, and so on. So I just want to shine some light on this before we start looking at the effects. Okay, so we are at the SOP create trees. This example is a combination of a few different workflows and tactics. Like I said, all of these are going to cover a bunch of things and hopefully make you more comfortable using Solaris and USD. At least that is my goal today. All right, so we have a SOP create here and we are creating trees. The way I did the trees here is you literally create a line, then you put a quick basic tree, lapse quick basic tree. This is the default tree. And then the way Solaris works, if you want to export different groups, you need to create a name or a path attribute. So this would work the same way if we did a path. And what are we doing here is, because the quick basic tree actually creates groups, leaves, stems, and trunk, we want to have access to these. So the way we do this, you can see right now, we only have a curve. So these are these curves that the Labs tool created and the unified mesh. But what you usually want is to, well, this is how you would create different groups. So now if we go outside, you can see we have leaves, stems, and a trunk, all in separate groups. Just to test my theory, here we go. If you have a path attribute or a name attribute, this is going to work. Next, on the SOP create, we are just creating a tree component right here. What is this? I don't know. So tree component, this could be also called something else. For instance, this could be called a small tree. So, or we could just say $OS. It's not a $. That is. So this would be under small tree, right? For now, I'll leave it to what it was, just so you know, this is where you change the hierarchy. And now I will use the reconstruct scene graph to do the thing that we could have done here. But, you know, I'm just creating extra work just so you guys can see how you can manipulate data. So what we're doing here is taking the tree, so reconstruct scene graph. Oops. We are taking the tree and we are saying small tree. New parent tree. There we go. So actually, if you just type slash, it's going to give you the first kind of path. So we are putting our tree under small tree. Great. Good stuff. And then just a quick null and then a configure layer. I'm not sure what I was doing here. Oh, I know. So if you don't have configure layers, when let's say you're merging things with a sublayer, this is going to complain because it's going to say like, oh, I don't have a safe path. And it's just going to complain. So if you put configure layers, he's going to be okay. And this comes back to, you know, putting explicit layer paths on your geometry. On the right side, we have a big tree. So it's exactly the same thing, but the line is set to 10. If we go to 20, it's going to make a bigger tree. So let's put it back to 10. And I'm doing something different here. And I'm doing this, again, just to illustrate and demonstrate a few different ways of working. So what I'm doing here is, this is still called SOP create. This is called small tree, like I showed it before. Like here, if I change the import path to slash $OS. This would be called subcreate4, which is not the best, but you know, big tree. And now it's going to be called, it has to recalculate, but now it's called big tree. Okay. Just going to go back. Subcreate. What I'm doing here, I literally went to type properties, or actually I went to edit parameter interface, and I added a string here. So you add a string and I called it name. You're going to get this name here, and here you can call it whatever you want. I called it big tree, and then you can copy parameter and paste relative reference here. So that way you can maybe copy paste, copy parameter, put it here as well, or you can create a null and use this as your control. There's a very cool tutorial from Adrian Lambert on YouTube, and he goes into a lot more detail on this, and he showcased a few different workflows using Solaris. So I check it out. Yeah, good stuff. So we can do something like this here. Call this character, apply it, apply. So you have your character, and here you would say, you would give it a specific path or a specific name then that you would later reference. So you can say character slash body slash nose, right? So you can copy paste, copy parameter, and paste references. So you can see char, body, nose. Okay, hope that makes sense. But that's different ways you can control things. For now, we big tree is good enough for us. So paste references. So we are under big tree. And then here, I am reconstructing the scene and calling this big tree 2. And I will show you in a second why that is. So when we are sublayering, if you remember, these things need to be named differently, because if they're named the same, way, like I showed you here, when we brought in our new animation, it had the same path except for the materials. Everything else was the same, so it's just gonna override it. It's gonna go on top of it. So if we, let's say, so this is all the same. We have tree 1, and this is big tree. If we didn't do this, if this was still called, let's see, so this is called tree, and this is, let's just call it the same, even though it's a different. So we have tree and tree. And now we try to merge them. This, like this. So you can see they're both called tree, and this is called tree. And if they're both called the same way, it's gonna, and by the way, we're saying sublayer inputs. When the sublayer comes in by default, you can bring in your files here. So, but if you put it to sublayer inputs, it will only look at the actual inputs. So now this is overriding it. That's why I have this reconstruct scene graph here. So even if I just change the name of 1 to, instead of just being tree, this is called tree 1, and then we have the component tree, this is going to work. But you can see it will still merge some things in a weird hierarchy. That's why if we do this and actually call this tree big, let's see, something is off. Tree. Oh yes, I know what it is. So this needs to be called the same, like that. So we are reconstructing it to tree 2, and now it still doesn't work. No, it does. Okay, we're good. So before it was misbehaving. Yes. And now this is called big tree. And I believe even if we change the name here, you can see the structure is going to be broken because this name has to match this. Because actually what we're doing here, we are just think as if we are just bringing in this big tree here, okay? And now the sublayer is gonna work perfectly. And our scene graph is gonna be in order. Okay, as you saw, a bit of shuffling around, a bit of changing different parameters, but I hope this is gonna showcase how this works. So here we have a thing called graph stages, which is also pretty cool. And it's another way of merging two hierarchies and graph stages. So let's plug in the first and the second input, and it's going to be a bit broken up at the beginning, but we are going to get both of our trees here by default. Let me try if I bring them in like this. So you can see, even though they, well, they don't share the same name, right? So let's put them back to tree. So tree, and graph stages. Even though they're both set to tree right now, it still merges them. And that is because this is gonna, see, this and this is all the same, but it's gonna merge it under SOP create. SOP create is this name here. So what this expression is doing, it's saying merge everything, but this is your destination path. Okay, our destination path here could just be big tree. So everything that comes under this input, put it under big tree. And what this is saying, just if we evaluate it, it's just gonna evaluate to tree. So this is lop input primitive, which is, I'm assuming, the first lop input primitive in this hierarchy. So even if we just set this, it would, was it the same? No. Well, in this case, it came under tree. If we just did slash, it would come separate. It would not come under tree. If we said tree, it would go under tree. Okay. Yes. So if we go back to our name, so this was called, I messed up the names again. This was called big tree, right? Big tree. All right, big tree. So big tree comes in, and we can also select, we want this to come in as a assembly or a group or a component. So our tree and big tree are both components, and now we can just say come under, or just come under our generic scene here, and that's how you can merge it under graph stages. I would recommend, when you're merging things, let's say here, when you're merging things like this, to use graph stages. In this case, the merge works because all the primitives and components that we have are named differently, so it's going to merge them completely fine. But like I'll show you, even the merge is going to have issues if we have two primitives that are named the same way. All right, so graph stages. I think I wasn't doing anything different here. No, so this came under tree, tree one. We can even say tree big. So now it's going to come under tree big and tree. So you can see if this is a completely new path, it's going to create a new path here. If the path is the same, let's say tree one, it's going to bring it under tree one. Okay, so that's another caveat. And then we have graph branches, another way of combining hierarchies and primitives. The difference here is you still select your primitive path under which you want this to come in, and then you here specify your the source prim path. So for instance, if we duplicated this and we say tree 3, so now this is called tree. It's going to come under tree, and we can do a sublayer, right? Sublayer, and it's going to combine our two hierarchies. And now we bring this in, and we can say we can now pick. I wonder why the picker is not working. but we can now pick tree 2, or let's make this different. Origin, oops. Or we can say tree 3. There we go. So we can now specify here what do we want to bring in. And as far as now, can we bring in both? Yay, we brought all the trees together. Happy tree family. Another cool feature that we can add is make destination primitive paths unique and treat destination paths as parents. And now we have all trees separate like this. So, you know, like I said, a lot of different ways of doing pretty much very similar things. And we also have the stage manager here, which I haven't mentioned at all. So with the stage manager, we can also rename our hierarchies. And let's say we have this here. We plug in the stage manager and we can see the same hierarchy that we have here. If we have variants, we can control them here. And we can also create, so we have trees and we can create a new folder and we can call this, mega tree, and we can do this. Yes, mega tree. So, you know, the more you know. Quick example of variants here. I was just testing out variants. So we have our small tree and our big tree. Big tree. Yeah, so big tree, small tree, they're both named the same. So I'm using tree on both of them. And then adding variants under tree. So variants source primitive. You essentially say, what is the source primitive, which is tree for both of them. And then variant set is my trees. You specify it. And now, if you put down a set variant, you can specify if you want the big tree or the small tree. So here we can add another one just to demonstrate. And we're gonna do 5, 5, and bigger tree. Okay, so we still call it the same. We're still gonna call it tree, bring it in, and this will automatically detect the, it's gonna detect this name. So set variants, so we're gonna have a bigger tree here now as well. This is just a quick example here on the side, just so you know. All right, let's look at this simple instance example. We have our big tree. We are reconstructing the scene graph, like we've been doing so far, and then configuring the primitive, setting it to a assembly. And then we're gonna instance this. You can see the configure primitive will not change anything. It's just a preference, but the scene reconstruct will, because this instancer is looking at our trees. So prototype primitives are our trees, which are, or our tree here, /tree. And then instance primitive path is how our hierarchy is going to look after. So here we can say instance trees, and that's how it's going to rename it. You can see we're not plugging in anything here because for instancing to work, you actually set up all of your necessary things inside. So we have a grid. I kind of look at this as a sock create, kind of a similar logic to it. Scatter points, creating a random orient and a random p-scale. So after we do that, we get a nice forest happening here. So that's how a simple instancer would work. And then you can also add different variants to this and so on and so forth. I'm not going to go too much into that, but just so you know, that's how you do simple instancing. All right, let's move on from the forest to some mega scans. So I'm going to introduce another concept here called purpose, and also show you how the materials is going to get linked when you are using graph stages, layers, heck, even frickin', even the merge is going to work, We used this before. If you remember here, we had our Orion character. Let me quickly initialize him. Here we go. So he has all the materials, and you can see the hierarchy, and the materials are here, right? So Char Orion, Geo Orion. When we brought in our new animated Orion, if we just bring him in as Geo, this is how it looks like. That is our character. It has the same hierarchy as our non-animated one. So if we bring it in into our existing hierarchy with all the materials, like so, and we just bring him in, you can see this part is just going to get replaced by the animated one, but the materials are still going to stay here because there was nothing to replace the materials. So now when we render him again, all the materials are going to be properly assigned to our animated Orion as well. There we go. So that same concept applies here. So let me go step by step. So we have a rock, classic Megascan rock. We have another rock on the other side with a poly reduce, and we're bringing them together. So you can see they're one on top of each other. The only reason this works is because, you know, this one is called proxy. Otherwise, this would just get overwritten or replaced because it's the same hierarchy from one to the other. There's this thing called the strongest and weakest position. I'm not going to get too much into that, but just so you know, it's here. Strongest position, just going to add proxy, right? Proxy. So we have both of them here. What we can do now is put down a configure primitive, and you would just drag in your proxy here, and then the purpose, you would set it to proxy. In this case, I'm not sure why I was doing this. Maybe I just left it here by mistake, but this can be also left to a component. So you set this purpose to proxy, and you do the same for your original one, and you set it to render. So now we are actually viewing the final render, or we can check the preview, or we can have both. But when we're going to render, we will only have the render one. And let's say if we put this to preview, we're going to have the preview rock, and now we render, and we're still going to have the render rock. So that's how you assign purpose. And this is good if you have a large scene and you want to have, you know, a bunch of rocks scattered or a bunch of trees. You can create proxy trees to then work in your scene without much lag, and it's going to be much easier on your computer. And then when you render, it's just going to switch to the render geometry. Okay, so we don't have any materials here, but we do have them on this side. So let me put down a material library. That's a weird error. Material library, and I'm going to copy paste this mud material here. So I'm going to connect it, and let's go to our sublayer, and I will put the final render here. So when we render, we don't have the material. What we have to do is assign it. So first off, the material prefix has to be, we're just going to keep it to what it was, which was Megascans and material. If you add something else to this, it's just going to add another layer, just so you know how this works. So we want it Megascan material, and you can see how that changed. And then we want to apply this material to a geometry. Now we don't have any geometry here, but we know on this side, we have this Megascan directory. So what if we just apply it to the Megascan directory? So we go here and we say, was it uppercase? Yeah, it was. Just say Megascans. And now we go here, and for some reason it's not applied. I think because we are missing a capital here as well. So you can see this Megascans is just going to get replaced by this Megascans. If we don't do it, I'm going to punch it here. So if we add a lowercase, it's going to create its own hierarchy. So it's not going to be connected. But if we put it in the same, under the same name, it's going to merge it like so. And now our material is going to be connected. And also because we are assigning it to Megascans, keep in mind, if this is not properly assigned to the geometry, it's also not going to work. So once you have all of these paths done properly, like so, we can then sublayer it, we can reference it, you can graph stage it, and it's all gonna work. There we go. So that's a way to assign your materials. I hope it makes sense. Simple merge. You'd think it would be so simple, wouldn't you? But it's not. Merging doesn't work exactly the same as you would expect in SOPs. So if we put down a SOP create, we put a sphere, right? A transform, and we merge these two. We get two spheres. That's what you would expect. But oh no, not in Solaris. And that is because the naming convention. So if we had a sphere, let me start here again. So we have a sphere. We do put down a transform. We can do that. We transform. And now we're going to merge. And you can see we don't get two spheres. And that is because this sphere here is still called sphere 7 all the way through. What we have to do is we can reconstruct, sorry, not reconfigure, reconstruct. So you can see immediately that's going to work just because this is going to put our sphere under a new scope. Obviously, what we would want to do is call maybe, so we would say, grab all the primitives and put this under sphere 2. So this is sphere 2 and then merge them. So that would work, right? So that's kind of what I'm doing here. You can see I am merging them. So transforming, putting this to right sphere. And actually in this case, I was renaming. So you can also rename not just reparent, but rename primitives. So old name, we just leave it to name, and new name is new name / new. In this case, it would say name was sphere 7, and now it's name sphere 7 new. So what we can do here, we would just call this right sphere, and it would rename it to right sphere, and now we can have right sphere and sphere 7. Cool. So that's a thing to keep in mind. Here I'm using graph stages again, very similar to what we've been doing before. Essentially putting our sphere, our right sphere, just under sphere 3. Here we can also put down a test to put this under a new hierarchy, and then we have our sphere 3 here. That would also work. You can rename this under your stage manager. So renaming this to sphere 5 and merging would also work. It would also work if you create a new sphere and just call it sphere 3, right? And now if we merge sphere 3 and sphere 7 or sphere 2, that would also work. Just keep in mind, it cannot be named the same way. So let's see what else I was doing here. So here we also have a sublayer to merge things, and you can see it's going to merge them completely fine as long as they have separate names. If it has the same name again, it's not going to work. So what you would have to do is, again, reconfigure layer, and now it's going to work. And then here on the left, we have a reference. So a reference will work by default. It's going to merge them together, but it will use this source name expression, and the source name is transform1, as you can see here. If we put this to right sphere, it's going to rename this to right sphere. So again, a few different ways of merging things together, and also using a merge. And then what I was doing here is after I merge, you can use another reconstruct scene graph to put both spheres together. So you would essentially just say, here you can select what do you want. And so let's see, by default, it comes in like this. So we would have the right sphere and a new parent. This is the new parent. What we here want is select the primitives. And I'm just going to say everything, select everything and put it under this new parent, which is both spheres. All right. Yeah. You can do the same thing with a stage manager. So like I showed you before, you click here, new folder, new child, more, new child, and put this child here, right? So good stuff. All right, simple merge. Hopefully it makes sense.